All right, so I'm going to go over how to do this practice quiz. And the quiz I'm going to give you will be very similar, just changing the things around a little bit. So if you can follow this, you should be able to do that. Hopefully you're able to make some headway on your own. Some of these are tricky. So I'm going to try to go through this kind of fast because this could take a long time. Okay, so the first one. We have this function. We want to estimate it around a equals 3, which means x equals 3. Okay, this is the format everyone says. They use a, but this just means x equals 3. And then we're going to use that to estimate the square root of 27. Okay, first, then, to always do this, all we're doing is finding we need a point and we need a slope. So we have to have a point and a slope, and then we make a linear approximation. So our point is x equals 3. When x equals 3, 28 minus 3 is 25, square root of 25 is 5, so y equals 5 then, and so we have our point, 3 comma 5. For linear approximations, we always do it around something that we know. That's easy. Square root of 25 is easy, square root of 16 is easy, square root of 27 is hard. So we estimate it, we linearize it around a point that we know, so that we can find it around a point we don't know and get an estimate. Remember, the whole idea is the square root curve looks like this. It's a curve, and we're saying, okay, at 25 right there, we're going to pretend it's a straight line. And as long as we're close to 25, it won't be too far off. So that's the idea. We're going to trying to find a straight line. So we need the slope then of our function, this function, at x equals 3. So to find the slope, you take the derivative. So y prime is, let's see, square root of the derivative of that is 1/2 28 minus x to the negative 1/2 times the derivative of what's inside. The derivative of negative x is just negative 1. So let's rewrite that. That's a negative, and everything else is in the bottom. We have a 2 in the bottom, and negative 1/2 is square root in the bottom, so square root of 28 minus x. That's our slope. We want to know that at x equals 3. So at x equals 3, so I'll do it the right way. Y prime at 3, we just plug in 3 there. That's negative 1 over 2 square roots of 25. Square root of 25 is 5, so that's negative 1/10, which maybe we can just write that as negative 0.1, a little bit easier. Okay, so that's our slope. Now we're ready to write our formula. Just use the old line formula. Y minus y1 is equal to mx minus x1. Our point is 3 comma 5, so y minus 5 is equal to our slope. We just figured out is negative 0.1, x minus 3. And so then, let's see, y minus 5 is equal to negative 0.1x. Let's see, that's negative times negative, 0.1 times 3, so plus 0.3. Add 5 to both sides, and finally we get y is equal to negative 0.1x plus 5.3. Okay, that is the formula for our line around x equals 3. So now we want to find out the square root of 27. Well, that's x equals 2. No, x equal 1, because our function is 28 minus x. To get 27, we plug a 1 in there, we get 27. So now we just plug in x equal 1 to figure that out. So in that case, when x equals 1, y is equal to negative 0.1 times 1, that's pretty easy math, plus 5.3. Which is equal to negative 0.1 plus 5.3 is 5.2. So our estimate of the square root of 27 is 5.2. So that's what we say is approximately the square root of 27. Okay, let's see what the real square root of 27 is. 27 square root, it's 5.196. So really, it's 5.196, which certainly rounds off to 5.2, so it works pretty good. Okay, that's how to do the first one. If you can't print out these files, that's fine. I can't either. My printer's not working, so just do it on a regular sheet of paper like I'm doing. For the quiz, this I'm not collecting. This is just for your help. But yeah, you don't need to print them out. But when you do turn in a quiz, just try to circle the answers really carefully and do the numbers really neatly so I can easily find it. Makes it a lot easier for me. Okay, that's number 1. Now let's do number 2. Okay, so number 2 is we want to estimate the sine of 58 degrees. Okay, so without using a calculator, hopefully. So number 2, we want to estimate the sine of 58 degrees. Okay, what I do know, I don't know the sine of 58 degrees, but I do know the sine of 60 degrees. You always look for one that you know that's close. And let's see, the sine of 30 degrees is 1/2. So sine of 60 degrees is the other one, which is root 3 over 2. Okay, that you know, or you should know, and now you know. So sine of 60 degrees is square root of 3 over 2, and I'm going to shut the wind curtains behind me because the sun is getting bright. Okay, hopefully that's better. Okay, so our function y is equal to the sine of x, and we want to do this at around x equals 60 degrees because we know the answer there. Then we can plug in, yeah, so that's what we're going to do. Approximate sine of x at about x equals 60 degrees. Okay, so we need a point and a slope. But we have a point. We know that when x equals 60 degrees, y is equal to the square root of 3 over 2. Now we need a slope, which is y prime. So y prime is equal to derivative of sine, which of course is cosine of x. That's pretty easy. And we want y prime at x equals 60 degrees. So y prime of 60 degrees is the cosine of 60 degrees, and that's even easier. That is 1/2. So that's our slope. Y prime, the derivative is the slope. Now we have our slope and a point, and then we just do the y minus y1 thing. So y minus y1 is root 3 over 2 equals the slope, which is 1/2, x minus x1, which is just 60. And let's see, so y minus root 3 over 2 equals 1/2 x minus 30, or y is equal to 1/2 x. So here is one problem we're going to run into right away. What if we're using degrees like I am here, it's going to get us a completely different answer than if we use radians, because we're going to mix it with root 3 over 2. And that's a problem, because if we had put radians in here, what would be the difference? Like, we could have used radians. The only difference here is these numbers. So whenever that happens, you know, oops, we need to use radians. So 60 degrees is the same as, what's that? Pi over 180 is, pi is 180, so 180 divided by 3, so that's pi over 3. So really we should use pi over 3. 1/2 of pi over 3 is pi over 6, so this should be a pi over 6. So now we have y equals 1/2 x minus pi over 6 plus root 3 over 2. And I'm just going to leave it like that. That's kind of messy. I'm not going to try to combine those two things. Let's just leave it like that. All right, so finally then we can finish this off with our, what is sine of 58 degrees? So sine of 58 degrees, we plug in 58 degrees here. So 58 degrees, okay, so here's the other tricky part. We're going to have to convert that to radians for this to work. So 58 degrees times, let's see, pi is the same as 180 degrees. So it's 58 pi divided by 180. And we can divide that by 2, so that's 29 pi divided by 90. Okay, so y then is equal to 1/2 of our x, which is that 29 pi divided by 90 minus pi over 6 plus square root of 3 over 2. And now, really, we said to 2 decimal places, so I guess you do need a calculator. So I guess, okay, that's a lot of math in your calculator, but if your sine button doesn't work and you can't take the sine of 58 degrees, then you can do all this math in your calculator. And then it's, at least you can do it. But the idea is the linear approximation, again, is we just approximate around something we don't know, or we do know, to find something close by that we don't know. And so we multiply all that out, and I'll let you guys do that. And then you can check it with your calculator. The good thing is you can always check your answer. Check sine of 58 degrees in your calculator. See if you're pretty close to the right answer. Okay, that's how to do numbers 1 and 2. Looks like this video is getting pretty long, so I'll make another one to do how to do 3 and 4.